Here in this video, we are solving 3 questions from the chapter Current Electricity that appeared in the NEET examination 2022. Let us read out the questions and try to understand how do we solve them. The first question is this: as the temperature increases, what happens to electric resistance? So to understand that how does the temperature affects the resistance, we shall know that there is a term called temperature coefficient of resistance, which is identified as variation of the resistance with temperature is directly proportional to initial resistance and also directly proportional to temperature difference between them. That proportionality is eliminated with a constant alpha R0 into delta T. So alpha can be expressed as RT minus R0 by R0 and delta T. This is called coefficient of temperature variation, coefficient of resistance with temperature. We need to know the things like alpha is positive for conductors. What do you mean by positive for conductors is, if you raise the temperature, resistance also increases. That alpha is negative for semiconductors and of course for insulators. What do you mean by that is, you raise the temperature, the resistance is not going to increase for the semiconductors, rather it is going to decrease for the semiconductors. So if you look at the options, with the increase in temperature, resistance decreases for conductors, that is wrong. Increases for both conductors and semiconductors, that is also wrong because it decreases for semiconductors. Decreases for both conductors and semiconductors is also wrong, right? So it increases with the conductors, for the conductors as alpha is positive for them. Decreases for semiconductors as alpha is negative for them is the right option. So option D is the right answer for that question, right? That's the first question, 18. Let's have a look at the 19th question, which says a copper wire of length given for you, radius given for you, has an electric resistance, current density in the wire for an electric field strength is also given for you. So I need to solve this second question, which is numbered like 19. That means this question I am solving actually. So we need to know the relation for the electric current density. So the current density is represented with a letter J is sigma into E, where J is current density, sigma is electric conductivity, E is electric field strength or electric intensity. Here current density we have to find out, field strength is given for you. So we need to know little more about electric conductivity. So let us try to understand try to know little more about this electric conductivity. We need to know one thing like resistance of a wire is directly proportional to length of a wire, inversely proportional to area of cross section. Proportionality is eliminated with a constant rho, which is called as specific resistance or resistivity. So that rho equal to RA by L, which is called specific resistance. People also call it like as resistivity. Now we get our term called conductivity. Conductivity is simply reciprocal of resistivity. That means conductivity is reverse of this, L by RA. Now I can write this formula as current density equal to, in the place of sigma I can write L by RA. Area of course assuming like a circular cross section, because radius is given for you, like written like pi r square and E. Now everything is available in the data. You can just substitute the numbers, like length is given for you as 10 meters. Electric field intensity is also given for you as 10 volt per meter. Resistance is also given for you in the problem as 10 ohms to make your calculation simple. Pi r square. Radius is given for you as 10 power minus 2 by root pi whole square. So let us simplify this. 110 gets cancelled, that is 10 by pi. 10 power minus 2 whole square is 10 power minus 4. Root pi whole square is pi. This pi and pi also will cancel. Minus 4 in the numerator becomes plus 4 and plus 1 is 10 power plus 5. So the unit for that is, the answer for that is 10 power 5. So the answer is 10 power 5. Like that I need to solve. So to solve this question, you need to know that basic concepts like electric field, electric density as sigma into E, where sigma is conductivity. I need to know that conductivity is reciprocal of resistivity, and of course we need to know how do you get that resistivity form concept itself. That's how we get the answer, right? Let's have a look at the next question. Two resistors of resistance 100 and 200 are connected in parallel to a electric circuit. The ratio of thermal conductivity developed is. Now, to answer this, you need to understand that how they are connected. They are connected in parallel, like it is given for you. This is what do you mean by connection? Parallel connection, 100 ohms and 200 ohms. One thing is, when they are connected in parallel, current is distributed, but the voltage is same in both of them. So what is the first thing that you need to know is, so we are solving this question here. This is this 20, yeah. In parallel, voltage is same. So I shall write the equation for the work done or heat generated in terms of potential, because that is same for us, right? I need not calculate that. We know the potential is defined as work done in bringing a unit positive charge from infinite distance up to a point. That implies work done equal to VQ. Q can be written like IT, basing on the definition of the current, as current is defined as rate of flow of charge. Q can be written like IT. I can be written like V by R using the Ohm's law, V equal to IR and T. So the work done which is generated as heat in the wire can be written like V square by R into T. That's the standard formula. Here being parallel, V square is same. The time is given as same in a given time for both of them. So what we can say is heat generated in the wire is inversely proportional to resistance. So H1 by H2 equal to R2 by R1. Resistance 2 is 200, resistance 1 is 100. So 200 by 100, that is 2:1. So the answer for the ratio of heat generated is 2:1. That's how we have to solve that question. Thank you for watching.